Hello, friend. This is our next part of Reflection of Light of Summary podcast. So, in which we studying the spherical mirror about. So, first we understanding what is spherical mirror. So, spherical mirror how looks like. You just take a ball and cut one side of the ball and take the small part of this our ball hollow ball. Okay, the shape of this ball cutted ball is look like our spherical mirror, same as this spherical mirror. Okay, this is our spherical mirror. Spherical mirror is curved mirror. Okay, now there are two types of spherical mirror. One is our concave mirror, other is convex mirror. Okay, so concave mirror, the inner side of the concave mirror is reflecting surface, and the outer side of the our concave mirror is coated. This is our concave mirror. What is convex mirror? The outer side of the outer surface of the spherical mirror is the reflecting and inner is coated. This is our convex mirror. You understand it, the spherical mirror how looks like, and what is concave mirror and convex mirror. Then we understanding the some terms related to the spherical mirror. Okay, so you have to take the book in which how the diagram you want once a time to look and once a time to read our textbook before the podcast also. Okay, because in this podcast you theoretically revise, so some diagram it could be difficult to me also to explain. Okay, so the pole in which have given, the pole is the center of the our mirror. Okay, then we have also in which the principal axis is the straight line passing through the pole and the center of the spherical. This is our principal axis. Principal focus. So principal focus, it define itself the first rule of our concave mirror or spherical mirror, that the point we have to be note, the incident ray comes on the spherical mirror and the incident ray must be parallel to the principal axis. Then the reflected ray is goes from that point, and this point is our principal focus. Okay, now in which have also the radius of the curvature, it is the radius of the spherical, and in which also have the center of the curvature, it is the center of the spherical, in which also have the focal length, the length between our pole and the focus. This is our focal length. These are the some terms related to the spherical mirror. Now we moving into next, that is our rules of the spherical mirror or concave mirror. The first rule we already defined by the principal focus. Okay, now first rule is what? The incident ray comes on the surface, and this is must parallel to the principal axis. Then the reflected ray passes through the principal focus, passes through focus. This is our first rule. Okay, then our next rule is what? If the incident ray comes through the our focus, then the reflected ray parallel to the our principal axis. This is our second rule. Now the third rule is what? If the incident ray comes perpendicular through center of the curvature, the center of the spherical, then the reflected ray follows the same direction back. Okay, this is our third rule. Now we understand it, the some rules of the concave mirror or the spherical mirror. Now we understanding the image found by concave mirror and convex mirror. So first we understanding by concave mirror. In concave mirror, by changing the position of the object, and then the position and nature and size of image will be changed. So first one by one we understanding every position in concave mirror. So first, the position of the object between pole and the focus, then the our position of the image is behind the mirror, and the nature is what? Erect and real. Only in this case the erect and real, in other inverted and real. Okay, and the size is magnified. Okay, so next, if the position of the object is at where? At focus, then the image, the position of the image is at infinity. And as said that the other all except this first, that the nature of the image is inverted and real of this. Okay, and the size of the image is very large. Okay, now we understanding the third. If the position of the object between focus and our center of the curvature, then the position of the image is beyond the center of curvature. Okay, now and the nature is inverted and real, and the size of the image is our magnified. Okay, then we understanding, if we take this position of the object at the center, then the position of the image at that same point, and the nature is inverted and real, and the size of the image is same as the object. Okay, now we understanding, if we take the position of the object beyond the center of the curvature, then the position of the image is between center of curvature and focus, and the nature is inverted and real, and the size of this is image is diminished. Okay, and if we take the take or put the our position of the object at a very large distance, it means at very it means at infinity, then the position of the image is at focus. Okay, and the nature is inverted and real, and the size is very point charge. Okay, point charge, these are the image formed by concave mirror by different position, at different position. Okay, now we're understanding in convex mirror. So in convex mirror, so easy to understand. In concave mirror, many position we have, and also this table sometimes make confusion for if you not clear in concept. Okay, now we understanding the image found by concave mirror. Okay, the position also we looking, so in which what the why the easy, so in which how the nature of the image does not depend on the distance of the object from the mirror. Okay, and these images in convex mirror, in where in convex mirror, always virtual, what always virtual and smaller than our object, and also situate behind the mirror. This is what in where in our convex mirror. Understand, then we understanding the divergence and convergence. You understand by the sticks of the our matchbox. Okay, the one end is contract. Okay, and other ends are how some distance as compared to the first, and these are the divergence. Okay, and you understanding the divergence of ray. Okay, also, and that the opposite we have the convergence, and we understanding by the sticks the ray of the lights. Okay, the divergence and convergence, converging light and diverging light also. Then we understanding we taking this some example of the concave mirror and convex mirror where they used. So concave mirror used in barber shop, dental hospital, in storage, and in various equipment using in solar energy. Okay, and in convex mirror, you looking the our car side the mirrors, these are our convex mirror. Okay, then we understanding our mirror formula. They before we understanding the sign convention, Castrian convention. Which sign convention? Castrian sign convention. In x axis and y axis, and in which we put the mirror. Okay, take the mirror, the position right side, it is our positive sign, left side we have negative sign, upward we have positive, downward we have negative. This is our Castrian sign convention. Then next we have the mirror formula. What is mirror formula? 1 by v plus 1 by u is equal to 1 by f. U is the object distance, v is the image distance, and f is our focal length. Then we understanding the magnification due to spherical mirror. M is equal to the, these are the formula by which something calculate. Okay, in we have the numerical to solve. Okay, so magnification due to spherical mirror. Okay, m is equal to height of the image divided by height of the object. This is our magnification due to spherical mirror. And also we completed our reflection of light in two parts. As a summary lecture you can revise. Okay, before examination, if not have the mood for the studying, then you can must revise through this podcast. So bye till now, you do must hard work. Okay, bye bye.